Good day, everyone. I am Allyssa Jhean Guzman, together with my group mates Klyde, Vincent, Agdeppa, Julia Francesca Dela Cruz, and Vincent Nicolas Pamfilo. We're going to present our project in machine learning under linear regression.
Here's a quick overview of what we'll cover. First, the data we selected and our main objectives, the data cleaning process, the data visualization, the correlation analysis, and finally, how we built and evaluated our linear regression model.
We used an insurance dataset that includes various features such as age, sex, BMI, number of children, smoking status, and region. Our main goal was to predict the estimated insurance charges based on these variables.
Before modeling, we clean the data to make sure it's ready for analysis. Data cleaning involves checking for any missing values or irrelevant data and making sure all variables are in the correct format. We also categorize data like sex or smoker into categorial, as well as age into numerical values so the model could understand them.
The next slide shows the plots that are used for data visualization. The scatter plot shows the relationship between age and insurance charges. Each dot represents one person. We can see that age increases, charges also increases, especially for smokers. The other plot, the histogram, shows the correlation between the frequency and the insurance charges. It helps to predict number of individuals who fall under the specific insurance charge. On the next slide, these are the code that are used for plotting the scatter plot and histogram. Based on the code, we initialize x and y variables to correlate their data and print the data as histogram and scatter plot graph.
The correlation matrix is a table that shows the strength and direction of relationships between pairs of numerical variables in the dataset. It illustrates the strength of the relationship between components of the dataset and the insurance charges. Values closer to 1, typically a stronger relationship between the components. Based on the correlation matrix heat map, the value closer to 1 is the smoker variable. The next is the age, next is the BMI, next is the sex, next is the number of children, and finally its region.
We trained a linear regression model to predict charges based on the input variables. To evaluate how well the model performed, we used two metrics. Number 1, mean squared error, which was around 33.8 million, tells us the average squared difference between actual and predicted charges. It means that your model's predictions are, on average, far from the actual values, and the errors, or the differences between predicted and actual values, are quite large. Number 2, R squared, which was 0.77, meaning the model explains about 77% of the variance in these charges. This is a good sign, although it is not perfect. R squared is a metric that tells you how well your regression model explains the variability of the target variable.
And these slides show the plot block of code. We assigned x and y values using charges as the y variable and the other components as x variable. In this block of code, we used train and test, wherein we used 70% of dataset to train and 30% to test. We categorized the numerical and categorical variables. When we train the datasets, we use linear regression to predict the charges based on the trained data in machine learning. Calculated both the mean squared error and the R-squared variables. To wrap up our project, we were able to build a basic linear regression model that can help predict insurance charges using features like age, BMI, smoking status, and others. We started by cleaning the dataset to make sure everything was usable, and then used visualizations to better understand the patterns in the data, like how charges usually go up with age and are much higher for smokers. We used the correlation matrix. We saw which factors were most related to insurance charges, and that really helped guide us in building the model. After training the model, we evaluated it using R squared, which came out to 0.77, meaning the model does a pretty good job explaining the variation in charges. The mean squared error was high, which shows that there's still some room to improve.